Hey guys, welcome back to the Geography Academy. Remember, this video is just a small part of a much larger course that's available below if you just follow the links and instructions. Part 2 of tropical environments is the landforms of tropical environments. Now we start off, there's going to be just a recap over the rocks and weathering section basically. Like from AS, just to recap all the weathering processes, then we're going to go into the features associated with granite and the features associated with limestone. So to start off, we just have to recap the types of rocks that are there and a quick recap on the rock cycle. So we'll begin over here where we have the magma. Magma is going to come up and is going to cool down, and when it cools down, it forms igneous rocks. So those rocks can be formed underground or they can be formed on the surface when we see it as like lava. But if they're not on the surface and they're underground, eventually those underground ones might become exposed, whether the ground layer is reduced or whatever might happen. But both of them then are going to be exposed to weathering and erosion. So weathering, the breakdown of the rock in place, and then erosion, external forces like ice, wind, waves and rivers that are going to come past and cause the breakdown of the rock. This then creates sediment. That sediment is then transported and could be deposited. When it's deposited, then it's getting buried, compacted, and goes through cementation. And during that process, then it can form sedimentary rocks where we can see the layers forming over time, compressing down and forming sedimentary rock. Now that sedimentary rock can then be uplifted to the surface where it is prone to weathering and erosion again, and that cycle just continues. However, the sedimentary rock then is quite often buried, so it goes all the way down into the metamorphic rock phase here. And in that phase, it's then going to form a new type of rock. So that's heated up. It undergoes heat and pressure in order to form metamorphic rock, which would be more resistant and harder than sedimentary. So that metamorphic rock then can end up on the surface too and be exposed to weathering and erosion, be broken down into smaller bits of sediment and continue that cycle. Or it could potentially be buried even further down and become melted and become magma again, where it can rise and become igneous rock. Now, igneous rock, before it has a chance to uplift, could be buried and also could create metamorphic rock again. So these are the rock cycles. It means we can go between 3 different types of rock and we can see how the different processes are involved. Make sure you're quite familiar with this before moving on. Now, a couple of things about each one. The igneous rock then is solidified magma. This is a way in which it solidifies, means that it has a strong crystal formation, and this means that it's very resistant to things like weathering in most cases. So a lot of mineral rich types of rock here. However, different igneous rock will have different characteristics because it'll have a different mineral composition. So that's how we define different rocks within a category like igneous rocks. Sedimentary rocks, then, the composition is going to be made up of more lightly, loosely packed sediment. Might be more susceptible then to different types of weathering or erosion in this area here. Metamorphic rocks, as we said then, is transformed igneous sedimentary or other or metamorphic rocks through the process of heat and pressure. And this can compress areas and reduce the amount of pores and weaknesses that it has, and can potentially then make it more resistant to weathering. Permeability then is quite important. So sandstone as a sedimentary rock, for example, has primary permeability. It has lots of pores and gaps. And if you look closely, you can make out the grains and the different layers that would have formed as the sediment was depositing and the pressure was put on it to form those lines and those layers. Same here with the sandstone. So the water can make its way through little pores that were left between these sediment there. And then you've got the secondary permeability to transmit water through fissures and joints. So we have that in the cracks and joints that are formed in this gray limestone here. So we can see easy enough water can pour down into those. So these two then will be pretty prone to different types of weathering then. The three types of weathering, the ones that we'll be focused on, is chemical weathering, decomposition, breaking down the rock, and through chemical reactions, water being a key role here. Mechanical weathering, best described as disintegration, so pressure causing a tear and breaking apart of the rocks. And then biological weathering, anything that involves organic matter that can cause then chemical or physical weathering through its presence there. Now, heating and cooling, thermal fracturing, we see that it's going to, a rock can expand and be heated during the daytime, for example, with very extreme amounts of temperature increase. So that can expand the rock, especially the outer layer of the rock, as opposed to the internal structure. That then is going to cool down and contract, and that expansion and contraction makes cracks in the rock, which will eventually then begin to just fall off. And as they're falling off and exposing more of a pure rock surface underneath, like here, that too will crack into little pieces eventually and exfoliate off. So the outside weaker areas then are exfoliated off there and peel away. Now, this process then can cause disintegration, thermal fracturing. We can see the kern sprung here, bigger rocks then split in two. Granular and block disintegration then ends up with different types of sediment.